Hello, I am Harsh from Team CloudyML. Welcome to our channel. Today, we'll be learning about the hello world of the NLP projects. That is sentiment analysis. Sentiment analysis is the most common text classification tool that analyzes the incoming message and tells whether the underlying sentiment is positive, negative, or neutral. This is a most common use case of NLP that has been studied and applied to the many experts by saying the state of arts approaches. Let's get started. In this session, we'll be identifying the SMS sentiment analysis. In that, we will be using this train CSV file. First of all, we'll be importing the necessary libraries such as pandas, numpy, portstammers, and such that libraries. For pandas, we'll be storing and analyzing the data. Import pandas spd. Now we'll be importing the count vectorizer that to get the frequency of words. In count vectorizer, suppose we'll be taking the example of these four sentences. The red dog, cat eats dog, dog eats food, red cats eats. These all the words that has been used. The red dog, cats eats and food. Suppose in the first sentence we have the red dog. The red dog will have 1, the red dog 1, 1, 1 and rest are 0. Similar to the second sentence that cat eats dog. 0, 0 here. Cat eats dogs 1, 1, 1 here. For third sentence we have dogs eats food 0, 0. In dogs we have 1, eats we have 1 and in food we have 1. This is the example of count vectorizer that we'll be using in this session. For count vectorizer, we'll be taking the feature selection extract from input count vectorizer. Next, we'll be also importing the some of the NLP libraries such as portstammer. This is the portstammer library here. Next, we will also importing the port RE regulation expression. We'll also import the stop words. And for visualization, we'll be using the cloud words. For cloud words, we'll input from cloud words, clouds, import word cloud. That is word cloud. We'll input this. We got an error, that is word cloud. For visualization, we'll be using the word cloud. Next, we'll use the matplotlib for pie chart, and we'll also be using the TF-IDF vector. For TF-IDF vector is a technique to quantify the words in the set of document that will communicate a scope for each word to signify its importance in the document. In this, the count vectorizer will use the technique of the document and it will give a significant scope. For count vectorizer, we'll be importing from the feature selection extract and the count vectorizer. Here we'll be importing the count vectorizer. I guess we have imported all the libraries. Now we'll be import the data. Data equal to read dot pt dot read dot csv. Here we copy the path. and we have imported. Now we'll see the head function top 5. So this is all the data that we have got here. Now we can see here that we have zeros and ones label, that is 0 for negative and 1 for positive. Okay, we have imported the data. Now we'll be downloading the packages for NLTK libraries to further pre-processing. So for pre-processing, we will be downloading the stopwords, that is nltk.download.stopwords. So NLTK will import here nltk. Now nltk.download downloads.stopwords. So stopwords, and in stopwords we'll be downloading the English language. So this is an English language. So we have downloaded the packages. So now to use the ports timing and the count vectorizer classes, we need to create these objects to use their functionalities. So porter is equal to ports timing object and count equal to vectorizer. So we have created the objects. Now we will be seeing the top 5 data of positive and negative labels. So for that we will be giving the pos equal to positive data labels equal to 1, and for same for negative. So first we'll print the positive data, print pos of head. So this top 5, the positive data that will be representing by the label 1. So same will be printing for the negative. So negative data label equal to 0 and top 5 negative dot head. So here is the top 5 data that with the label 0, that is for the negative label. So now we'll be visualizing with the pie chart. So for pie chart we'll be using the matplotlib library. So in this fig is equal to plt.figure equal to 5 by 5 figure size equal to 5 by 5. So we'll count the label, that temp is equal to pos label dot count, and same for negative, that is negative label dot count. Now we'll be printing the pie chart. So for pie chart we use this. So in its syntax. So I guess there is a mistake here of and comma duo. So we have the 50% of positive data and the 50% of the negative data in the data set. So there is no bias between the positive and the negative data. So here we have the 50% of positive and the 50% of negative. So now we'll be pre-processing our data. So we'll create a function for that and we'll apply the pre-processing the data for that. So for pre-processing, we'll call up the pre-processing pre-process and we'll pass the text here. Now we'll use the regular expressions here. So text equal to re.sub and here we will use the regular expression above. And the text will check off the emoji to emoji.re.find l and we'll have this expression here. Next we'll be also checking about the emoji and replacing with the space. So in this we'll be checking about the emoji and replace with the space and we'll convert them into the text.low. And after that we'll return the text. So we'll run about this and so we have run. Now we'll applying the data. So data equal text equal to data text text and we'll apply the pre-processing pre-processes pre-processes and we'll run and we have an error. And what is the error? Fine. Okay, we'll run this and we have again an error. So in findel we have done a mistake here. We have findel emoji. So we'll search for the parameter. What's the error? And I guess we have mistake in the findel. And run. I guess the data has been run here. Yes, we have done the mistake here by not passing the parameter here properly. We have only passed this parameter. So after applying the pre-processing, we'll check the pre-processing data that is there. So here we have passed the data and all the text has been into the lower. So next we'll be tokenizing our sentence. So we will make a function of tokenizing. We'll pass the text here and return the text dot split, and we'll check with an example tokenizer hello world of NLP. So we have got the tokenized sentence. So we can pass our data set into here. So okay, now also we'll also do the stemming part here by making a function. So stemming will be the function that converts the words into its base form. So you can try with your examples too. So suppose for stemming, we'll tokenize user.porter and we'll do text. Now we'll return the porter dot stem dot word word and for word in text dot split. I hope is the right and the data has been right. Oh, so now we have done the two pre-processing here. First we have tokenized our sentence and next we have tokenized dot porter. That is, we have used the stemming function here. In stemming it will convert the words into its base form. So after doing this, now we'll segregate our data into the positive label data and to the negative label data. So for that, for positive for positive data equals to data into data label equal to 1. Equal to 1. So we will give the data to positive data of text. So it will take the positive data. For negative we'll do with same and change the label 1 to label 0. Negative data. Only we need to change the negative. Oh, we have done with the negative label data 2. So now we'll be plot our data with the word cloud. So for that we will be using this function to plot the data. So in this we'll be first joining our data. So for positive data we print. So first I will tell about the function. Here we will be joining with our data. For that, they will clean the word with this list comprehension method. Indeed, they have used the color background color is equal to white and the width is equal to 2500 to 2000, and it will generate the clean data, and the figure size will be of 10 by 7, and it will show only the one figure. So in this it will show the most used words that have been used in the positive data. So it will take time to run this data. The same do for the negative data too, and we'll change the background is equal to black. Oh, so we have here. So the most likely words are like, time, no, great, well, good, part, much, also, give, to, think, scenes, characters, and these are all the most used words in the positive data. And same for the negative data, it will show in the background, and it will give us about the negative words that have been used in the data set. So it will take time to run. So here you can see we have got the negative words that have been used more: bad, character, nothing, probably, whole word, something. These are all the negative words have been used in the negative data, that is in the label 0. So after the visualization, we will be creating the TF-ID vectors. So in vector, we'll be creating the object first. So we have created the object. Next, we'll be giving the y data and x data. So for y data, we'll be giving the data dot label dot values. Next, for the x data, we have into the text format, and we need to convert them into the vectorization that has been applied to the data, and it will be stored into our x value. So for that, we'll be scaling our data into the fit transform method of the the TF-ID vectorization. So it will take time to run because it is in the text format to transform the data. So after transforming, we need to split our data into the test and train. For the logistic regression, we need X and Y trend so for testing and training data. So in this, we will be taking the 50% of data for the training and 50% of the test. So here we'll be importing from sklearn. We have model dot slash selection, and we need to import train, test, and split. So train slash split. So we'll be taking x train, y train, x test, y train, and y test equal to will pass the train test split and x comma y and random state equal to 1, and we'll be taking the test size of 0.5, that is the 50% of the data. You may change the data upon the 0.3 or 0.2, but I will be taking to a 0.5, that is 50% of the training data and the 50% of the testing data. So now our model is ready. So now we'll be importing the logistic regression. So logistic regression is used in the classification problem, such as to classify between the classes, such as in this we have positive and negative, that is zeros and ones. So logistic regression will work here very better because it is used in the classification. So for that we have from sklearn dot linear model, linear slash model, and we need to import logistic regression CV. As we have imported, now we'll be creating its object with the logistic regression CV. Model equal to logistic regression of cross validation equal to 6, and scoring will based on accuracy, and will give the random state equal to 0 and max iter equal to 500, and will feed our data into train and y train. Will feed it. It will take time to run. Oh, we have done a mistake here. We need to pass extreme. I need to stop this runtime and run it again, because we have passed the wrong parameter. We have passed the extent, so it will pass the extent. And so till that time it's running, we will be predicting our model that for white bread equal to model dot predict the x data that we have passed. X data is the test. So after taking a lot of time in the training session, around 2 to 3 minutes it takes to run the training process of the model. So after running the model, we will predict our model on the X test. So after doing the test, we need to check the model accuracy. So for that, we need to import the metrics from sklearn. So from sklearn, we'll import metrics. Yes, we have. Now we'll print the model accuracy. So for print accuracy of the model will predict dot accuracy score will pass y test and y pred. So our model accuracy is around 0.89, that is the 89%. So we'll multiply with the 100 to get into the percentage. So around we have 89% of the model accuracy. You can change the test size around 0.22 or 0.3 so to increase the model accuracy, or do some feature engineering into this data set to increase the model accuracy. So we can also evaluate a model with the help of the confusion matrix. So in confusion matrix is a matrix that is used to determine the performance of the classification model for a given set of test data. So the structure of the confusion matrix look like this. It has four types such as true positive, false negative, true negative. So for true positive, we have the predicted value is the positive and it's positive in nature. So for the false positive, it is also known as the type 1 error. So it will predict the value is positive but it is false in the nature. For the false negative, it is also known as the type 2 error. So the predicted value is the negative but it's positive in the nature. So for the true negative, the predicted value is the negative and it's negative in nature. So its structure is look like this. So for the actual value, it represents in the columns, and for the negative, for the predicted value, it will represent in the rows like this. So it will help to evaluate the performance of the classification models when they make predictions on the test data and tell us how the model is good or bad in the nature. So with the help of the confusion matrix, we can also evaluate the different parameters for the model such as accuracy, precision, recall, etc. So here we can print the confusion matrix. For that we need to make like matrix dot confusion matrix. So we'll pass the y test, y pred, and we'll do. We also will print. So we have got the matrix. So here we have the true positive. We have 8783. For false positive, we have around 1228. For false negative, we have 929. And for true negative, we have 9060. So by looking into the matrix, we can also print the precision recall too with the help of this confusion matrix. So for that, the formula of the precision and recall will become, so for precision, it can be defined as the number of correct outputs provided by the model, and for the recall it will be defined as the out of the total positive classes how our model predicted correctly. So for precision, the formula will be became like this: TP upon TP plus FP, that is false positive. And for recall, the formula will slightly change: TP divided by TP plus FN. So here we have the formula. We can also print directly by using the classification report from the matrix. In that we can also got the model accuracy, precision, recall, and the F1 score too. So for that we'll print the matrix dot classification report. We'll pass the y test and y spread. So here we got the precision, recall and the F1 score. For the precision 0, we have the around 0.9, that is 90% of precision, and of 0 in recall we have around 0.88 recall, and for 1 we have 0.88, and for recall we have 0.91. And finally we have also print the model accuracy around 0.89. So as you can see here, we have the 89%. So this was all about the mod of the Hello World